35 then. Because I solved the problem with you, but I didn't solve it. Remind me your name.
Michelle.
Michelle. Very good. 1.2.99. 97. Very good. From my math lab. Okay. So now did we find the percentage?
No, I wasn't able. It won't load on mine.
Okay. So let's come up with the percentage.
5%.
Okay. So let's see. Yeah, that works. So if the percent, so always when you read a problem, a word problem, please read it carefully and identify what the variables mean. So this is percentage of adults who do blah, blah, blah. Now X is the number of years since, I believe, 1970. So now when I'm asked, find when the percent is 5%, then you know what to do. Because you establish the fact that this is the percent, and you are given this, 5%, and you are asked to find when. Because X is the number of years since 1970.
For this particular problem,
Yes.
I noticed I had some confusion on it, and when I finally figured it out, I realized that for if you pull up the actual question, it says years since 1975, but what it's actually asking for is the years since 1980. So X is going to be equal to 20 for both of them. If you read the question, if you struggle with it, I know
You are talking about a different one. You are talking about the two models, C1 and C2. We're not talking about that problem. This is a different one. This is the one with the percentage of adults smoking since 1970, blah, blah, blah.
Oh, okay.
It's a different one. That's okay. That's okay.
I had trouble with that.
Okay, so let's finish this one. So this is a linear equation. I have to move 35 to the other side. Negative 30 equals negative x over 2. Now, if you don't have 5, Michelle, if you don't have 5 and you have something else, just replace it. It's the same, right? So then I will multiply both sides by negative 1. And I get 30 over 1 equals x over 2. And we know what this is. What is it? A proportion, right? So 1 times x is x equals 2 times 30, which is 60. So this is 60 years since 1970, which means which year? That's it. This may not be your answer. You know what I mean? We just pick the percentage. Okay, any questions on this problem? Is this okay now? Okay, is there anything else that you need help with? Anything else? Anything else that you worked on? Anything else that you need help with? If not, we will go back and try to finish factoring. Okay, so here's where we are. We completed everything on this list, but I like to pick another problem from here. So everything here is done. Now, I do have some examples with equations and other things, but we're going to go through these in the course anyway. So I only want to refresh your memory on factoring for now. Okay, so do we continue with factoring? Do you have any questions for me? Anything? Okay, so let's go back to trinomials. So I'm back to this page, choosing something else from here. I think we did this problem, just this one. So let's do the first one, m squared plus 13m and plus 42. So I have to go through all those 4 steps. So remember, first, so this is the strategy. I have to ask myself, what is it? Then I have to arrange it in descending order if it's not in descending order. Then I have to pull out the greatest common factor and the negative leading coefficient if they exist. And then I'm right here in the middle with the strategy, because it's a trinomial, correct? Yes?
Yes.
Perfect. So then I'll say, is it in descending order? Yes. Greatest common factor? No. Negative leading coefficient? No. So now, is it a special product? It's not a special product because 42 is not a perfect square. I always hope and wish for a special product, but it means that this has to be positive and a perfect square, but 42 is not. So now I move on to the next strategy that says whatever and the leading coefficient 1. Yes, it's this one, is this step. So now I need to find two numbers whose product is 42 and whose sum is 13. So this quantity with the sign is always the product. This number with the sign, not the variable, is always the sum.
7 and 6.
Okay, perfect. 7 and 6. Only two numbers work. No one can find another pair of numbers that work. So both conditions have to be fulfilled. 7 times 6 is 42, and 7 plus 6 is 13. Both conditions must be fulfilled. So then I know that this is factorable, and how?
M plus 6, M plus 7.
That's it. M plus 6, M plus 7. And that's the easiest type. I shouldn't say the easiest. Some of them with larger numbers may be cumbersome. Yes, please.
Is there an easier way to find the two numbers that, because that's what always takes me so long. I'm not good at like multiplication in my head. I have to like always actually do.
It's a very good question. So what I would do, I would look at 42 and present it in prime factors. It's an even number, so it must be divisible by 2. And then I have 21. So 21 is not divisible by 2, so I go to the next prime number. So it's 3. And this is 7. So now 42 is 2 times 3 times 7. So I have to use all these factors, but come up with only two numbers whose product is 42, because I'm using all of them. The product has to be 42, and the sum is 13. So that's how I know that I have the 6 and the 7. 6 times 7 is 42, and 6 plus 7 is 13. So that's another way. I would present the prime factorization, and I put them in ascending order and try to find two numbers whose product is 42 and whose sum is 13. As an alternative method. Okay, so now let's move on to the next page. This one at the top. And let's say I'm going to pick the first one for now. So 6y squared minus y and minus 1. So again, I have to go through the strategy, all the steps. I cannot skip anything. So it's a trinomial. Is it in descending order? The answer is yes. Greatest common factor? No. Negative leading coefficient? No. Special product? I always wish. No. 6y squared is not a perfect square of anything. And negative 1, furthermore, it cannot be negative, and negative 1 is not a perfect square. Is 1 the leading coefficient? I wish. It's not. So this is the last chance. If this doesn't work, I will write that the polynomial is not factorable. This is the last chance I have to factor a trinomial. Okay. And this is, of course, the most difficult type, in which it's not a perfect square and the leading coefficient is not 1. So here's what we need to do. We still have to find two numbers whose product is, in a moment I'll explain, and whose sum is. The sum does not change. Can anyone tell us what is the sum going to equal to? Of course. However, whenever the leading coefficient is not 1, the product is not the last number, but the product of this number and the first and the coefficient, the leading coefficient. So it is negative 6. And you can say, wait a minute, why didn't you incorporate this in the product? I did. 42 times 1 is still 42. But here, I have no choice. It's negative 1 times 6 must be the product. The sum does not change. There is no change ever about the sum. So now I have to think. Can I find two numbers whose product is negative 6 and whose sum is negative 1? Here's how I start. Here's my thinking process. The product is negative. If the product is negative, I cannot have two positives, and I cannot have two negatives. I must have a positive and a negative. One more time. The product is negative of two numbers. Obviously, one has to be positive and one has to be negative. They cannot be both negative. They cannot be both positive. Correct? Perfect. So then, can we find two numbers whose product is -6 and sum -1?
-3 and 2.
-3 and 2. Do you all agree with -3 and 2? Is the product -6?
Yes.
Is the sum -1? Perfect. But now, please do not do this. This will be incorrect. Y plus, don't write it, I'm going to erase it. And y minus 3. Why is this incorrect? This is what we did before. That's all we did. We found the two numbers, and we wrote this. Because the leading coefficient was 1. But the leading coefficient is not 1, and this will not work. Y times y is not 6y squared. So there is an intermediate step. So this is incorrect. So here's the intermediate step. I'm going to continue here. I copy 6y squared. But now, instead of -y, I will use what you just gave me and create -y from positive 2y and minus 3y and then minus 1. I did not change the problem. This is still -1y. But I used the two numbers you gave me. Now the next step is, if you go back and combine like terms and get this, you're going backwards instead of forward. We worked hard to determine this. We worked hard to find two terms that replace -y. Why? Because now there is a method called factoring by grouping. That works for 4 terms. But you can say these are not 4 terms. Go back and combine these two. Then I won't be able to factor. I want 4 terms. What will you factor out from the very first 2 terms? You're going to factor out?
2y.
Very good. What is left in parentheses?
3y plus 1.
Excellent. What should I have? I covered it. I refuse to look because I may come up with something that is not correct. I may. What do I have to get in parentheses from the other 2 terms? Because if I don't, I can continue. Please. Then I will not be able to factor. It has to be identical. If it's not, that's why I write it without looking. I can make it up, right? So now I need 2 things in here. I need a sign and I need a factor. So now I look. Exactly. -1 times 3y, -1 times 1. So now what is the common factor that I will pull out from these 2 terms? Of course. And what is left in parentheses? Something from the first and something from the second. That's it. And this is the most difficult type. Why? Because after I find the numbers, I cannot write the factor form. I have to go through one intermediate step in which I change 3 terms into 4, and I use a method called? Correct. So now, we're going to have more examples in a minute. Look at the last strategy. What does this say? Nothing, but
Factoring by grouping.
that's it. So for 4 terms or more, factoring by grouping. So when we get to working on polynomials in a minute, we go to, what is it, a polynomial, descending order, greatest common factor, negative leading coefficient, nothing, no special products, nothing, directly to factoring by grouping. That's the reason why I insist to show this method here of factoring by grouping, because I can use it here and I don't come up with a different situation. Okay, so let's choose more. So let's say 4x squared minus 4x minus 15, and then we can look at the other two. So please do the factoring supplement or factoring homework in my math lab before you attempt 1.5. Okay, because that's what it is all about. Ready? Okay. Descending order, it's a trinomial. Descending order, greatest common factor, none. Negative leading coefficient, no. Special product, I wish. 1 is the leading coefficient, not even that. So it's the last chance. It's the most difficult type in which I have to find two numbers whose product is and whose sum is. Let's start with the sum. Correct. But what about the product? Correct. So I have to incorporate. So this is negative 60 is the product. Perfect. Good. So now I have to think. I have to try to find two numbers whose product is negative 60 and whose sum is negative 4. Okay. Perfect. I was going to ask you, since again the product is negative, 1 must be negative. And since the sum is negative, the number with more power must be the negative. Yes, exactly. Now I cannot blindly go and write the factored form, but I have to, this is the long procedure. I don't have a name for it. It's the long procedure of factoring. So what will I continue with? Can anyone dictate what we have now? Very good. By the way, the order is not important. You can write 6x minus 10x or negative 10x plus 6x. It doesn't matter. Yes. Is this the same thing with this? Because if it isn't, we change the problem. But if they are the same, we didn't change the problem. Are they the same? Is negative 10x plus 6x the same with negative 4x? Yeah. Very good. So then what was it? It was minus, yes, it was minus 15 because I wrote on top of it. Good. And when I cover the last two terms, I am not kidding. I strongly recommend you don't have to cover them, but do not look at the other two terms before you establish what you factor out from the first two. And what do we factor out from the very first two?
2x.
What is left in parentheses?
2x minus 5.
So if I don't get a 2x minus 5 coming out from the other two, I will not be able to factor. Now, let me just say this. Will I draw immediately the conclusion that it's not factorable? No. So I may have to factor, and we'll see that in polynomials. I may have to try to group the first with the last and the middle two. I may try to group the first with the third and the second with the fourth. And only after I exhaust all these three possibilities and nothing works, then I'll say it's not factorable. Okay, now I need two things. I need the sign and the factor in front. So the sign is? Good. And the factor is? Do you all agree with 3? As long as it works. I cannot just make it up. Is 3 times 2x this?
Yeah.
Is 3 times negative 5 that? Yes. Good. So then I can continue, and now I pull out the common factor, which is? Very good. And something must be left over from the first term, and something must be left over from the second term.
2x plus 3.
Now, let's say you have doubts about this. It only takes 5 seconds to check. Let's do it together, okay? Bless you. 2x times 2x, positive 6x minus 10x, and negative 5 times 3. You can always just take a few seconds and check. Any questions on this? Okay, let's look at, let's say one more. Let's say 2x squared plus x plus 1, unless you need more. Okay, so what is it? A trinomial. Descending order. Yes, greatest common factor. No. Negative leading coefficient? No. Special product? I wish. 1 is the leading coefficient? No. So this is my last chance. If it's factorable, I have to write what? I have to look for two numbers whose product is
2.
and whose sum is good. So since the product is positive, I'm expecting either two positive numbers or two negative numbers. But since the sum is positive, the numbers cannot be, they cannot be both negative, correct? They both have to be positive. So can I find two positive numbers whose product is 2 and whose sum is 1? The answer is no. So what do I write? Not factorable. Your book and my math lab may require you to write prime polynomial. I disagree with the prime word, but they may ask you to write that. It's fine. I'll give full credit if you write not factorable or prime. I'm okay with that, but I prefer not factorable. Okay, final step in factoring. Polynomials. So we talked about strategy for binomials. We talked about strategy for trinomials, which was the most difficult. And now this is the last step, strategy for polynomials. 1 through 4, same. What do I mean by the same? What is it? Descending order, greatest common factor, negative leading coefficient. Number 5, what is number 5? None? Look at the strategy. Exactly. That's it. There's nothing else. That's the easiest. Okay, so let's look at C at the top. 2x cubed minus 6x squared plus x minus 3. Ready? Okay, so it's in descending order and it's a polynomial. Greatest common factor to all 4? No. Negative leading coefficient? No. Grouping? Okay, fine. Again, I may have to group in 3 different ways. First 2 and the last 2 is one way. First with the third and second with the fourth is another way. First with the last and the middle 2. But I will start by doing the first 2 and the last 2. If it works, what will you factor out from the first 2? Very good. What is left in parentheses? What should I have from the other 2? Otherwise, I can't continue. I'm not going to fabricate it. It has to be there. I have to have x minus 3. Do not write anything else. Write this first before you figure it out, because you may be tempted to write anything else. I need 2 things. Some students write like this. No, do not. I need space. I need a sign, and I need a factor. Plus 1 indeed. So then the factor form, I'm sorry, yes, the factor form of the polynomial, but what is the greatest common factor here? Very good. And what is left in parentheses? Remember, there are 2 terms. Something has to come from or be left over from the first, plus something has to be left over from the second. Why? Because if I go back and redistribute, x minus 3 times this has to give me this, plus x minus 3 times this has to give me this. So what do we have in parentheses? That's it. Do you think we need another polynomial, or can we move on? One more. Very good. So please choose another. Yes. DS in dog?
Yeah.
Yes, of course. Oh, that's already halfway done for us. Because it's already, as you see, it already has the factor.
So let's do E then.
That's since I wrote it, let's do both. Okay, so perfect. So then there are 2 terms, and they have a common factor, which is
X plus 2y.
exactly. So now in parentheses, something must be left over from the first, which is something must be, very good. Now I reach the positive sign, and something must be left over from the second. Very good. So what does this equal to when I combine like terms? An apple plus an apple, 2x minus 3. And that's it. Yep. Yep. An apple plus an apple. Okay, and you also want to look at e, you said? So a squared plus 6a plus 9 minus y squared. This one is different. Here's why. If I try to factor out from here, what will I factor out? And I have a plus 6. There's no a plus 6 that I can pull out from here. If I group these two, I cannot even pull out anything, and nothing from these two. If I try this with this, and these two, I will never get anything that works. However, there is one other way just for this one. In this scenario, I will have to group the first three together and leave the last one alone. Can anyone tell us what a squared plus 6a plus 9 equals to? It's a trinomial. It's in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product. Exactly. Exactly.
So it would just be a plus 3 squared minus 5 squared.
Very good. However, that's not the end. So thank you for that. And now here's what I have.
The difference is squared.
Exactly. It is a difference of squares. Correct. Something squared minus something squared. How do I get that? Well, the difference of squares factors into a positive and a negative. So I can write it inside. I didn't have to write it there. Actually, I'm going to erase it. So the first one is a plus b, the first quantity plus the second quantity. And the second one is the first quantity minus the second quantity. Can anyone give us the plus?
Would it be a plus 3 minus y?
But plus first.
Yeah, yeah.
It doesn't matter because I put plus in front. You can write them the opposite.
And then a plus 3 minus y.
That's it. Because we had a plus b and a minus b, and this was a squared minus b squared. Yes, that one was different. Very good. Any questions? Any questions? Okay, now I would like to go to one document that I have in here. We'll find it in a second, which is this one. So right after factoring, you have simplification by factoring. You can read it if you want to, but I think I'm going to make it way easier for you than reading this. However, you may want to read it. Okay, so we're going to look at a couple of these problems. Here are the final answers. And then the other, you choose 2 in class, and the other 5 you'll do at home for Wednesday. Before that, before you choose, I want to talk about something similar so we can have the concepts down, and then we can choose whatever you choose. So let's say I have x to the 4th plus x to the 3rd minus x squared. These are 3 terms. And it's a trinomial, descending order, negative leading coefficient, no. Greatest common factor. Is there a common factor in all 3? And you will say yes, and you will factor out x squared. In other words, you compared 4 to 3 to 2 and you chose the smallest power, because only the smallest power goes into all the other three, all three, right? Can I choose 4? No, because this one doesn't have 4, and this one doesn't have 4. Only this one has 4. So I have to choose the smallest power, and which is 2. So now, after I do that, and choose x squared as the common factor, which makes sense, then what do I have in parentheses? How many terms did I start with? I have to have 3 terms. X squared, I'm going to let it dry and I'll put a 2. X squared times what is x to the 4th?
X squared.
Right. So multiply, copy the base, add the exponents, plus x squared times what is x cubed?
X.
And minus x squared times what is x negative x squared?
Negative X.
So if I put negative x, then I copy the base and add the exponents, and I will have 3.
So -1.
Exactly. Is this clear? No matter how difficult these problems look, it's this concept. I will pull out the smallest power, no matter what. So if I have 7, 5, and 2, I will still have to pull out 2. That's all it says. And all these expressions can be simplified by factoring. So now please choose anything you want. The concept is the same. I will choose 5, and you'll choose the second one. Is that okay? So 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, times 2x plus 1, plus x squared plus x plus 1 to the 5th, times 4, times 2x minus 3 to the 3rd, and times 2. Yes, it took me a whole minute to copy it.
What, can I see that packet that you have?
Yes. It's the next handout in the sequence. Okay, so my first question, how many terms we see in this problem? So we have to differentiate between factors and terms, right? So when I say factors, the quantities are multiplied. When I talk about terms, the quantities are no. That's okay. That's okay. So factors and terms. So this is extremely important to understand the difference between the two. Ready? So let's say 2x multiplied by 5y cubed. What will you say this and this? Of course, I can also say 2 and x and 5 and y cubed. But what are these two quantities? Since they are multiplied,
10x1.
they are called factors. What about 2x plus 5y to the 3rd? This is a binomial, correct?
Mhm.
So this is the first term and this is the second term. That's why we say how many terms? Binomial, right? So these two quantities now are called terms because they are added or subtracted. When we talk about factors, the quantities must be multiplied. When we talk about terms, the quantities are added or subtracted. Are you with me, everyone? Okay, so now let's come back to our problem. One more time, the question is, how many terms do we see? How many? Terms. How many terms? So you start from the very beginning, and you're looking for an addition symbol. This is a factor, this is a factor, this is a factor, this is a factor. Oops, edit. To a factor times a factor times a factor times a factor. So one more time, how many terms? Yes. We have term, first term, and we have the second term. Very important to establish that from the beginning. Why? That's exactly what we did here. Remember when I came up with this example, I said, how many terms? Why is it important? Because knowing how many terms I have, I factor out the common factor, and then I have something left over from each. If I have 2, I will have 2 leftovers. If I have 3, I will have 3 leftovers. If I have 5, I will have 5 leftovers. That's a crucial question. Are you with me, everyone? Okay, perfect. Now, I notice also that the first term is pretty simplified. The number alone, the factor alone is outside. All these are okay. But here I don't like the way it's presented. I see a 4 in the middle as a factor, another 2 in the middle at the end as a factor. These two numbers, when I multiply them, I get 8, and I have to put it in front. So that's my first step. So from here, I will rearrange. I will copy the first term as is, 5 to x minus 3 to the 4th, x squared plus x plus 1 to the 4th, and 2x plus 1. And I will continue with 8. X squared plus x plus 1 to the 5th, and 2x minus 3 cubed. So in number 1, I established that we are looking at 2 terms. My second question is, do they have common factors? Do they? I don't know. I'm looking at the numbers first. No, 5 and 8 have nothing in common. Is this common to both? Which power do I pick? Remember the simple example that we looked at before? Indeed. Then I continue. Is there anything else in common? I know this is in common. Is there anything else in common?
X squared plus x plus 1.
Which power I have to choose? Correct. Now please open brackets. You may not like them, but it's the wise thing to do. Now, how many quantities will be left over? It depends on how many quantities we started. How many terms did we start with? We started with 2 terms. So something has to be left over from the first. And then when I reach the plus, I will write plus, and something must be left over from the second. So what is left over from the first? I don't know. Let's take a look. 5 is not pulled out, so it has to be inside. Now, from those 4, we took out 3 of those. Is there 1 left over? So in parentheses, don't forget 2x minus 3. Sorry, I will erase that. I don't know why I meant to write positive, but it's negative. Okay. Good. So now, this is, so 5 is in, 1 is left over. Now, these 4 are completely out. So there is nothing left over, but there is something else, a factor that has to be taken into account. I reached the plus symbol, plus. Okay. 8 is outside? No, it's not. Now, 2x minus 3 cubed, 2x minus 3 cubed, they're all out. But I took out x squared plus x plus 1 to the 4th, and I started with 5. Is there 1 left over?
Yes.
Correct. I'm going to erase the bracket because I ran out of room, and I will put it again in a minute. So I have to multiply. Bless you. I have to get rid of this. It's not working anymore. I hold on to it to show the factoring, but okay. So multiplied by, what will I multiply it by?
X squared plus.
Very good. And now I close the bracket. Perfect. So the two factors, I'm going to copy them. 2x minus 3 to the third and x squared plus x plus 1 to the fourth. And now I'm inside. I need to distribute all these, and I need to distribute 8 in here. So I don't know where you want to start. You want to start from here, you want to start from here, it doesn't matter. 2x times 2x squared times 5. Perfect. 2x times negative 3. Negative 6x times 5. Awesome. 1 times 2x times 5. And then 1 times negative 3 times 5. Very good. Now I'm here. I distribute 8 to these three quantities. Plus 8x squared plus 8x and plus 8. I'm almost done. I copy the first two. No one changes that. We can't. And now I can use a parenthesis for the rest. 20x squared with an 8x squared is 28x squared. Negative 30 plus 10 is negative 20. But negative 20 plus 8 is negative 12x. And then finally I have negative 15 plus 8, which is negative 7. And this is the result of adding two kind of weird terms, changing them into complete factors. This is the first factor, this is the second factor, this is the third factor. Questions?
Is
Okay.
this on a thing? Is there like a video of this or something?
Yes, I just recorded it. Can I just get that back so I can choose another? Good. So please choose another. Any of these. So another option is you will read all these step by step, and if this makes sense to you. Another option is you come and see me earlier next time or stay after class and we can work on some problems. 7. So we want to look at 7. So at 7 we have 4. 2x minus 3 cubed times 2 times 5x minus 1 squared minus 2x minus 3 to the fourth times 2 times 5x minus 1 and times 5, and everything divided by 5x minus 1 to the fourth.